Hello, I'm Ivana Yovcheva. I'm an open source engineer from VMware, and I'm going to talk about serverless and the OpenFaas framework. And what you're going to see in this session, you learn about serverless and how the OpenFaas framework is related to it. We will talk a little about GitOps, and you'll see 3 demos. So what is serverless? It's not about servers. It's not about the lack of servers. I know we live in a high-tech era, but we are still not on the point where you don't need a computer to run your application. So serverless is the concept that you can bring your idea into a real product without worrying about the infrastructure. It's about working on what really matters. And what's the history of application development? Previously, there was only the monolith. This is a heavy, huge system that has every part in it. And if one part of your system is consuming a lot of resources, this means that the whole system will slow down. You can have problems. And if you need a new feature in any part of the system, or you want to provide a bug fix, then you need to release the whole system, which means days or weeks of testing of everything just for a single part. And after that, people came with the idea of microservices. And they are the idea of separating things that are not necessarily connected. And if they can run on separate VMs, if one part is consuming resources, it does not affect the others. They have separate release cycle. You can bug fix one of them without affecting the rest. And it not only helps your system and for it to be faster, but you also help your development process. But it was not enough in all cases, so people came with the idea about functions. And this concept is that if you have parts of your application that are stateless, they are short-lived, they are single purpose, then they don't need to be part of a microservice or a whole system. And this is a quote from Alex Williams' book for serverless. People say it's not a good practice to read from presentation, but I'll be a rebellion and read this quote because I like it a lot. It says that we use serverless to decrease the time from our idea to getting the end product in our customer's hands. So it's about not worrying of anything side of what your idea is and any other component infrastructure. And this is how simple handler of a function looks like. This is what your idea implementation can really be. This is just a simple Node.js example, but this can be as complex as your needs are. And you may ask yourselves, okay, how I can have my idea, my code working just with a single handler file and a piece of code. And this is why Faas frameworks came to life, and I'm going to talk about one of them. I'm going to talk about OpenFaas, and I'll tell you why. This is a project that was started in 2016 by Alex Ellis, who did it as an experiment. He just wanted to try, is it possible to have serverless experience over Docker containers? And he started writing the framework at nights, Saturday and Sunday, out of his work just to try it out. And since then, it now has more than 14,000 stars on GitHub and more than 150 people devoted to contribute to the project. It has full-time team from VMware, which I'm part of. It's led by the author, Alex Ellis. And this is how I learned about serverless, about the framework, and how I started to contribute to it. And it won a BOSSY award in September for best open source software. And it also has a lot of production users. So why I fell in love with this framework? First, because it's complex in terms of feature that it provides, and it's a real thrill for a developer to work on something like that and or some new and interesting area. But in the same time, it's easy in terms of how you use all those features. You can have OpenFaas running on absolutely any platform, any machine that can Docker running on it. And this really means saying you can have it on a Raspberry Pi device. And you're not limited of languages that you can use. You can write your Golang solution, your Python solution, or you can even turn your old Fortran code into a function. And you can write your functions in Pascal. How many of you use Pascal here? Oh, you're a traditionalist. Yeah. And the other good thing about it is that you don't have any limitations in terms of what resources you can use. For example, if you have millions of requests to your function, you can scale it as much as you need to. You don't have limitation of number of replicas of your functions. And you also don't have any restrictions about how big your function can be. It can be gigabytes if you wish to. And it's because this is not a hosted system, it's a framework. With hosted systems, you have a limit. Because yes, you for example, with AWS Lambda, you can't have a function more than 100 megabytes. And this is how you can create your function using the command line tool. You just type a command with the name of your function, language you'd like to use. We provide language templates in a lot of languages, but if someone needs a language that's not in the official templates, then you can write it on your own, and a lot of people in community and end users write templates for other languages. This is how we also adopted the PHP template. Someone from the community wrote it, and we added it to the official repo. And this is handler code, or code of your function, and all your dependencies written by you or side dependencies that you can attach. And what happens here is that your function is built into a Docker image. It can be pushed in any available Docker registry, like Docker Hub, Quay, Harbor. This is what we support because this is what people requested, but it's an open source project, so it's a good place to add new features. After you push your images, you have backup of them. You don't even have to store them in your computer, and you can use them directly from the Docker registry. And after that, they are deployed to your cluster, Kubernetes or Swarm cluster, and you can have them available. This is a diagram of how the architecture of OpenFaas is. It has several components that are deployed to the cluster by Kubernetes, but it can also work with Swarm. And you have API gateway. This is the way you can connect to your functions from outside. You can have access to your function and invoke it from anywhere. If you are running OpenFaas on a GKE cluster or EKS or somewhere else, you can create ingress controller or load balancer, and you can access the gateway. It has Prometheus running as a service in the cluster, and this is it's collecting metrics for your functions, and you can open Prometheus and check what's happening, see how many times your function has been invoked, how many replicas it had in periods of time, and etc. And your functions are deployed in a separate namespace. From the OpenFaas framework, you can attach custom resource definitions to them. And this is another part of the OpenFaas components. It's the watchdog. What it cares about is that your function is not worried about where the requests come from and where they go. It just receives std in and outputs std out, and does not care about the rest. The watchdog is listening for HTTP requests. It's sending them as std into the function, and then it's taking the request back, the output from the function, and bringing back to where it took it from. And it's a forked process that runs and listens. But you can also have your functions running with any available queue system. And this is an example with Kafka. We wrote Kafka connector that listens to Kafka topics and then invokes functions that are labeled with the same topic. And this diagram shows that the OpenFaas framework can run can work for any events without the need to change the framework. If you can have separate solution to work with any event system, and these are other queue systems that our community provided support from. Just if someone needs a system, they just create their solution and contribute. This is an example of how you can define Jenkins cron job, and it can invoke a function every minute. And we'll talk a little about the life cycle of a function. You create your code, you put whatever you want there, and after that, you use the command line tool to build it to a Docker image, then push it to a Docker registry and deploy it to your function. And when it's deployed, a container is created for it, and you can invoke your function when you need to. And if you need any changes, you just edit your code and build, push, and deploy it again. We have a single command for that. We call it fast up. And here it's now time for a demo. I'll show you how you can create and run your function. This is a stake.yaml file that has two functions defining it, weather demo and weather app. With listed images. This is the code. You don't need to read the code. I'm just showing it. And later I'm going to explain what the functions do. And if we go to the terminal, then you can see we just write fast up. And our functions listed in the stake.yaml file are now built and deployed. So now, this is, you can see we have image listed, image name. One is in Go and the other is in Python. This is the code of the first one. This is the handler. This function is a weather application that uses available weather API, makes calls to it for a certain city, and returns the weather. And the other function has events for OpenFaas, and it says about the town where events are held, what the weather is going to be. So we copy the gateway to the function URL, and then we open it in a browser. We can also invoke it from the command line, do whatever we need. And this is what the function outputs. We have a list of events. We have cities where the events are held. And then we have the weather there. And we can select a month of events. And this is what is coming next week in KubeCon. There will be a talk in Seattle. So we'll go back to the terminal. And you can see if we want to see the Kubernetes definitions of all the deployments, services of both function, a secret that we need to use the weather API. We're going to list them now, and this is this huge YML. And if you want to use it directly with Kubernetes without any framework, you need to write all this on your own. And think about it, read about Kubernetes documentation, how to define it. And then when we go to the stake YAML file that you define your functions, it's just as simple as this. You have your images, your language template, you can have environment variables, labels, and this is the secret that we use for the weather API. Let's create it in Kubernetes, and it's then referenced in the stake YML. And if we go to the code, this is the place where we consume that secret and use it to access the weather API. And this is a diagram of what happened. We have function 1 that takes a list of events. Then it has a list of cities where the events are held. It calls function 2 that uses the weather API, which collects the data, and then brings it back to function 1, and function 1 prints the result. So this is how in 4 files you can, one stake YML and 2 function codes, and one HTML page. In this example, you can implement your idea. It took me yesterday afternoon to implement this, and this is how you can have an idea of a mobile application or something like that, and it's that simple to bring it to real. You don't need to care to worry about your infrastructure and anything else. So what are the values of our project? We saw now that the developer is the first that is important for us, because the idea is to ease the life of a developer. Later, in the next few slides, I'll say why it's operator friendly. And we are community-centric because we are driven by our community. We rely on it, and the community is what helps the project grow. So this is it. It's our team serverless. It started from 1 person in 2016, and it grew that much for 2 years. We have Zoom meetings very often. We meet on conferences where we go together. We have Fast Friday initiative on Twitter. So if you want to get some Slack for OpenFaas, you can just tweet for Fast Friday and get yours. And there are people from all ages. And as you can see, there is plenty of room for you to join the community. We also have production users that trust OpenFaas and use it for their systems. And I'm going to show you 2 of them. This is Patricio from Visual Banco. They have a home banking service, and they are using OpenFaas for their customer requests to their home banking service. And what they say is that since they start to use the framework, they don't have any problems with system crashing, slowing down, because it's running separately, it's handling the requests, and it can cover their demands. This is how their building looks like and how their system looks like. And another use case in production is from Icon Scout. What they do is they work with designers and end users. The designers create logos and other things that people need, and then people go to their system, they select what they want, and then buy it. What their system does is not just uploading and downloading, but it also converts every image to many different types, JPEG, SVG, PNG. It creates plenty of sizes of it. And for sort of special users, promo packets, it's creating a zip file with a lot of images and all types of versions in it. And in the beginning, they used a monolith application for this, which means when it comes time for designers to upload a lot of data, the system starts processing all this data, and their system was slowing down, sometimes crashing. They had a lot of manual efforts to control this. They tried with microservices, but it was not enough for them because they were still processing everything on the same machine. They also tried some hosted fast solutions, but they had problems with some restriction, and what they say is that they still had some manual efforts, which they didn't want. They wanted to forget about doing anything from those apps and their application to run alone. And then they used OpenFaas, and it really helped, and they were so happy that they wrote a blog post for us. And we mentioned, I showed you an example how the framework can help a developer, but there is another side of things. Okay, you want to adapt something new, but you need to learn a lot about it, about every framework. And maybe you don't want this, you just want to forget about everything else and just write your code. And you just won't forget about all the rest of a picture and take care only for this. And this is Ivan he's a Kubernetes consultant, and this is what he believes about serverless. He believes that you can focus only on writing your idea, and you should be able to don't worry about the frameworks. And this is actually the GitOps idea. How many of you don't use Git? Anyone? Okay, you can go out. I'm just joking. Yeah, so what GitOps is? It means that you can use Git and any platform like GitHub and GitHub and etc. You can work on your code, you can push it there, and this can be the only thing that you do. You don't need to worry how your code is consumed, how it's tested, and etc. And this is how we created OpenFaas Cloud. It's actually built from functions, as I'll show you later in a diagram. It's a managed system. It can have multi-user support, and separate users are not able to see the other users' functions. It's for a CI/CD process, which means that you don't have any release cycles. You just push your code, and the change is already available. And we have a free community cluster that can be joined, and if someone wants to try the OpenFaas Cloud, you just need to ping Alex, or as I'll show later in the context, and you can try it out for free and have your functions running there. But you can also create the cloud on your own machine. There is a dev guide for people that want to use it on-prem. And this is how it works. Like, you write your code, then you push it to GitHub, and the OpenFaas cloud takes care of the rest. It builds, pushes, and deploys your functions, and you have it running. And this is a diagram of what's happening behind. As I said previously, it's built from functions. We have the guitar function that is taking all your code. It's making a tarball from it. Then it's invoking the build ship run function that takes this code, builds it, and deploys it to the cluster. It creates logs for your function, and you can see it on your dashboard. You don't need access to a cluster, don't need to use any commands. You can directly see your logs of the build and of what's happening if your function crashes for some reason. You can also use Geode Secrets, which means that if you have some sensitive data, as I had previously with the demo, I needed to use a secret for the app ID, for the weather app. And maybe if I'm using some place like this, some common cluster, I don't want to upload my private data there. And this is why I create Geode Secret. And then I just use it in my code. This is how the dashboard looks like. You have a link to your function endpoint. You have a link to GitHub or GitLab. We have support for both. GitLab is still not official, but it's available. And you can access your logs here. And I'm going to show you a little demo about the OpenFaas cloud. So just imagine that your production broke like this. There was something, but it disappeared, totally broke, and you want to fix it. And you can do it just as simple like this. You go to GitHub, you open your code, you do a fix here, and after that, your function is directly built, pushed, and deployed again, and you have it running. Here, I'm just writing a commit message. And after that, I can check in commits. There is a status for that commit. What's going on, that the build is proceeding. Then I can go and see what's happening. What I did actually, I commented a few lines of code just to make it look bad on the home page. And here we're waiting the build to be done, the images to be pushed, and then it's deployed again. You can see the logs of the function build. And if we go, yeah, this is how the stack looks like. It has link to dashboard. And if we refresh, our production is fixed. And it's how easy it is. You just edit your code in GitHub in this example, and you can have it available. This is the dashboard. We link to our endpoint. You can link to your GitHub repo. And I'm going to show you another demo. It's a repo. I created an issue bot for GitHub. It's a repo. This is the code. You don't need to read it all. It's the issue bot code that will apply labels to issues that are created in your repo. And I defined a webhook in the repo that is linking. I think I'm going to show it here. It's with videos, you have to predict what you're going to do next. This is the webhook. This is a link to my function. And here I set an event for issue comment and issue create. And my function is invoked if this happens. I'm going to paste something from Twitter about CI/CD. It's not a fully positive message, so it's going to put a review label on it. I'm creating an issue. here. And now there is event that issue is created. It invokes the function, gives the body and the name of the issue. The function is processing it with sentiment analysis. It finds the message negative, and then it puts a review label. Now I'm going to create a positive one. I wrote that I like ISTA. It's my first time here, but it's good experience. And it's now going to take the body again. It's invoking another function called sentiment analysis that will take this data and calculate if it's a positive or negative message. And it's now going to put positive label. And this is the code. So what we saw by now, we saw the OpenFaas cloud. It had multi-user. If you saw the link on the webhook, it was prefixed by my username. So you can have a separate root, a separate domain to your dashboard, your functions, accessible only for you. And it's developer native because you just edit your code. What's coming next about both OpenFaas and OpenFaas Cloud? We are going to provide full GitLab support for the cloud. It's already available, but it's not merged in master yet. We are testing. We tested a lot of times. The demo with the issue bot was running on GitLab, and we are going to merge it very soon. For OpenFaas, there is a Kubernetes Workshop. We now have a workshop that's only for Docker Swarm. That's available on GitHub. If you follow the labs, you learn how to use OpenFaas easily. It's in Python, and now we added Kubernetes instructions as well. For it, we have new fall designed t-shirts. If someone is interested to contribute, you can contact Alex and get your t-shirt. These are the links if you want to join Slack and ask any questions. Our community is very responsive. If you have any issues or questions, you can try the workshop on your own, and you're always welcome to join the team to contribute. Open a pull request. This is our main OpenFaas user, and all repos that are containing the framework are there. And this is everything from me. Thank you for your attention. If you have any questions. Аз обаче нямам... Sorry, I don't hear very well. I'll come here. Sorry that the rest will not hear, but...
My question is, you are an open source developer in VMware, right?
Yes.
So in kind of way, VMware is a sponsor of that initiative. What's the expected return of this initiative?
So the question was that I'm an open source developer for VMware, and VMware is supporting the project, and what VMware is expecting back. And so first, I'd like to differentiate that it's separate. It's open source project. It's not owned by VMware. It's running separately, and the reason VMware is supporting full team, this is actually the reason why our team exists, because VMware uses a lot of open source projects in its products, and this is a way to contribute back and be a good citizen. And also we contribute on, not on randomly on open source projects, but we contribute to projects that the company uses. There are a lot of serverless solutions in it, and a lot of teams use OpenFaas. And this is why the company finds it valuable to contribute to this project. We contribute also to Kubernetes, kernel shell, etc. I'm part of the serverless subteam only, but we have a bigger open source team that's contributing to other projects as well. Any other questions?
So how do you scale beyond the single Docker instance? How do you scale beyond the single Docker instance? How do you scale horizontally when the infrastructure is your limit? So if you have a function which goes beyond your local deployment or the instance which you are running on top, how do you manage that?
So when your function is invoked a lot, we have, I actually forgot what, we have a lot of components in OpenFaas. I think it was the alert manager that cares of it, but we have it implemented. It's using Prometheus. It's checking how many times, how frequently a function is invoked, and if it gets some limit, automatically Docker is creating more replicas of your function, and it's creating actually more and then your function is invoked from different replicas, and you can put limits. It has not any up limitation by default, but you can define limits in your stack YML file as a maximum scaling if you don't want to a single function to consume too much your resources. And if you put maximum limit to 1, then your function will not auto-scale. We also have fast idler, which we developed separately, and we deployed to the same cluster, and it's taking care that if you can define what functions it can work on, what's the period of time your function is not being invoked, and if your function is not invoked for a given time, for example, half an hour, the idler can scale it down to 0, and then you will not have any replicas for this function, but then how the gateway works is that if a function is scaled down to 0, if you invoke it for the first time after it's scaled to 0, it will create a replica again. It takes up to 5 seconds, depending on the function, to scale it back and to directly invoke it without you taking care to create replicas. Any other questions?
So my question is about running this fast cloud in a corporate network. So not actually connecting to github.com and not actually connecting to a Kubernetes cluster. So can this be set up separately and used? And
Yeah,
how is it to configure
maybe,
if yes?
Yes, this is something like what we did. It's, I don't know about how to achieve this with GitHub. We use it with GitLab. And the demo you saw for GitLab, it was running privately. It was one of my colleagues' cluster. It has no side access. He created Kubernetes cluster, and we created. With GitLab, you can have your private access to an instance, and we set up the cloud there only for this instance. It cannot be accessed from outside, and it can work in your system only.
So you can have a private GitLab instance, a
Yes.
private a Docker registry that is not Docker Hub, and you can.
Yes, actually, you can define, for example, the cloud can also be work not with any online registry, but you can create a Docker registry on your machine. Just create it from command line on Docker and store all images there. And yes, it can. It's what you saw the example for Vision Banco. They were the force for us to create GitLab support because they want to use it there. And they also need it private because they are banking system.
And one last thing, does it only work with Kubernetes or Swarm?
It
can be
works
also-
both with Kubernetes and Swarm.
Okay, thanks.
Any other questions? Then thank you, and if you still have something to ask, you can find me after the talk. I'll be here in the hall and attending the conference, so thank you.